the sinkhole, except the hydrocarbon in the sinkhole is weathered. Anytime you get hydrocarbon out in the environment, part of it's going to degrade. The microbes and everything will degrade it. And so what we're seeing is an identical signature, except for what we call the real light ends that the bacteria attack first. But the signature is identical, and the signature also looks like crude oil. So that's consistent with what was said about a refiner's coming out. They've taken a look at it. They said it's marketable crude. Our analysis is totally consistent with that. We are looking at where's the gas coming from, where's the hydrocarbon coming from. What we can tell you right now, I do not have all the answers, but the gas in the cavern and the gas coming up around the sinkhole is not coming from the Crosstech butane cavern. We've eliminated that. It is not coming from the Acadian cavern, and the Acadian cavern's way over here anyway. We've eliminated the Acadian cavern, sorry. And we're still evaluating the data from the Chevron cavern. Right now, the data we've got, the gas in the Chevron cavern and the gas in the Oxy 3 cavern are very, very similar, and there's no real distinction that we can make. But the gas in the Oxy 3 cavern also looks like just regular natural gas coming out of a gas production well. Okay, so we're working on it. We're isolating things in terms of gas sources as we can. Right now, where we're at on that is some of the gas may be left over from the 2003 incident. We're looking at that. I talked about the Chevron cavern. The other likely source we're looking at is gas and crude coming in from the gas and crude production horizons that are around the dome. Right now, at the elevation of the cavern, the top to the bottom of the cavern, according to the 3D seismic that's been done out here, there are three historical production zones that are at the same elevation of the cavern. The Big Hum, the Chris R, and the Mary V. Those are all oil and gas producing zones, and so we're looking at those. We're going to get a petroleum geologist in to help us isolate that. So right now, that's where it's at. In terms of the discrepancy between Texas brine volumetric records, where everything they put in diesel-wise equals about everything they took out, but now we got 1,300 barrels in a frac tank. If the source is coming in from crude, that resolves that discrepancy. That there is crude oil coming in to the cavern. We talked about the hydrocarbon. It is crude. We'll have written reports, but it's all but certain that it's crude oil is what the liquid is. The other thing that we've done, we've been monitoring bubbles around. People are seeing bubbles around. We're monitoring those. We've sampled all the way from Grand Bayou over to Pier Park. The bubbles coming up in the vicinity of the sinkhole have a lot of similarities to the gas that's in the cavern. Okay, they're a little different, but they've got some similarities. The bubbles that are coming up far to the west over at Pier Park are swamp gas. That's what they are. They're just natural swamp gas coming up that everybody's seen. And the way we distinguish those is we use what's called isotopes, which is a fancy word for how we break apart the molecules and measure their weights. That's how it's done. And I could go into a long explanation, everybody would go to sleep and we'd have a good old time. But all this is done with isotopic ratios and carbon ratios. Well-established science. This is not hocus pocus stuff, but all this differentiation is being done on isotopic ratios. So you're going to hear more and more of that, but that's how we're doing it. So to reiterate, the bubbles far to the west are not related to this. The closer we get to the cavern and sinkhole, the more the gas bubbles look like the gas that we see in the cavern. That's it.